Welcome to The Explainer. Today we're looking at something really cool, a blueprint for how to build an AI that doesn't just calculate, but actually thinks. We're talking about a machine with something like genuine common sense.
All right, so let's just dive right in with the question that's on pretty much everyone's mind these days. It's not just sci-fi anymore, it's a real, serious discussion. Are we actually just a few years away from true artificial general intelligence?
And what's just wild is how fast things are changing. I mean, just look at this. In 2020, the experts were saying, yeah, maybe in 50 years. Fast forward to 2024, and that number has crashed down to just 5 years. 5! So you can see the conversation is totally shifted. It's not if anymore, it's a very serious when.
Okay, so before we go any further, let's make sure we're all on the same page about what we're even aiming for here. Right now, we have what's called narrow AI. Think of it like a master chess player or a brilliant translator. It's amazing at one specific thing. But the goal, the real holy grail, is AGI, or Artificial General Intelligence. That's a system that can think, learn, and solve problems across all sorts of different areas. You know, kind of like a human.
So, the big question is, what's the holdup? Why don't we have AGI already? Well, according to AI pioneer Yann LeCun, and this guy knows his stuff, he's a Turing Award winner, the biggest hurdle isn't what you might think. It's not about needing more data or faster computers. He says the real missing ingredient is something much more basic: common sense. And here's his big idea. You can't just code common sense into a machine. It's something that has to be learned. Think about it. You, me, even your dog, we all have this intuitive grasp of how the world works. We build these internal world models just by living in it. LeCun's whole argument is that if we want to build a truly intelligent AI, we have to teach it how to do that exact same thing. Okay, so how do we actually do that? Well, he points to 3 massive challenges we need to solve. First, the AI has to learn by watching and observing, not just by doing. I mean, you can't have a self-driving car learn by crashing a million times, right? It's just too slow and dangerous. Second, its reasoning process has to work with the math that powers all modern AI, something called gradient-based learning. And third, it needs to be able to think on different levels at once, understanding the tiny details while also keeping the big picture in mind. This brings us to LeCun's actual blueprint for building one of these intelligent agents. And what's so brilliant about it is that it's actually inspired by a really famous idea from psychology about how our own brains work. He basically designed the system to have 2 different modes of thinking. And if you've ever read Daniel Kahneman's book, Thinking Fast and Slow, this is going to sound super familiar. You've got mode 1, which is all about fast, gut reaction thinking. And then you've got mode 2, the slow, careful, analytical part of the brain. So mode 1 is that pure instinct. It's the don't think, just act system. You see a ball roll into the street, you slam on the brakes, there's no deep reasoning. It's a straight line from seeing to doing. It's for all those automatic skills we've learned over time.
But then there's mode 2. This is the inner chess player, the strategist. When the AI faces a really tricky problem, it doesn't just react. It actually stops and thinks. It comes up with a plan, runs simulations in its head, what happens if I do this, figures out which outcome is the best, and then tweaks its plan to make sure it gets there. It's all about thinking before you leap.
Now, the real magic, the absolute core of this whole thing, is the engine that lets it do all that planning. Because it's not just about predicting the future, it's about predicting it in a really, really clever way to deal with a fundamental problem. And what is that problem? It's that the real world is an absolute mess, right? It's chaotic, it's unpredictable. If you try to build an AI that has to predict every single tiny detail of what's going to happen next, like which way every leaf is going to blow in the wind, it's just going to fail. It's impossible. So how on earth do you make a plan when the world is fundamentally unpredictable?
Well, LeCun's answer is this really elegant piece of engineering called JAPA. And the big breakthrough idea is simple. Just don't. Don't try to predict everything. Instead of trying to create a perfect pixel-by-pixel video of the future, JAPA learns to predict only the important stuff, the abstract concepts that actually matter, while totally ignoring all the random, unpredictable noise.
It all comes down to abstraction. The system literally teaches itself to ignore the things it can't predict and that don't affect the outcome. So it doesn't care about the precise flutter of each leaf on a tree. What it does care about, and what it learns to predict, is the important, high-level fact: that tree is about to fall over.
And this is where it gets really powerful.
You can actually stack these things. Imagine a low-level JPA that's focused on the next few seconds, making really detailed predictions. It then passes its abstract summaries up to a high-level JPA, which uses that info to think about the next few minutes or even hours. It's like having a manager and a worker, letting the AI think and plan on multiple timescales at once.
All right, so let's zoom back out and put all these pieces together. How does this all add up to a machine with real common sense?
So here's the formula, basically. You take these powerful world models that can adapt to different situations, and you combine them with this ability to plan hierarchically, both for the short term and the long term. And what you get is an agent that can finally do what we call common sense. It can reason, it can predict what's going to happen, and it can intelligently fill in the missing pieces of information.
Now, it's really important to see how this is a huge departure from what we see today. LeCun is pretty clear that systems like the large language models we're all familiar with, because they only learn from text, have a really shallow understanding of reality. It's brittle. This whole approach, on the other hand, is aimed at creating what he calls grounded intelligence, an AI that's connected to a model of the actual world, not just a world of words. Look, this blueprint isn't the final answer to everything, but what it does is give us a concrete, believable roadmap. It shows us a way to get beyond AI that just recognizes patterns to building machines that can truly reason about the world. And that leaves us with one heck of a final question to think about. If we actually pull this off, what's the very first thing we should ask these new thinking machines to do?